You will see this chemistry question on your MCAT.
Question 2. This one says, a student plans to add hydrochloric acid to a solution containing lead nitrate. To determine how much lead cations will precipitate from solution when the hydrochloric acid is added, the student needs to know which of the following. So there are a couple of ways to approach this question, but we need to recognize that this is a solubility question, okay? And what we have in solution to start with is actually a salt, which if we were to add it to water, the following reaction would occur, okay? Where this, as a solid, okay, would dissolve to form lead 2 plus 2 of these, I don't actually need the brackets there, but ignore the brackets, but 2 of these nitrates, okay, -1. So this would be that reaction, okay? If you add hydrochloric acid, we know it's a strong acid, so this will dissolve completely in water to form protons, acidifying the solution, and chloride ions. Now, what can happen is that the chloride ions can actually react with lead to precipitate some lead chloride, okay? And the reaction would look like this. It would be the reverse of this reaction, actually, okay? And this is a reversible reaction I'm indicating with the 2 arrows, so you can get lead 2 plus 2 chloride ions, right? So if you have a bunch of lead in solution and you add chloride ions by dissolving hydrochloric acid, the chloride ions would react with the lead, right? And that would potentially precipitate some lead chloride. And whether or not that would happen would actually depend on what the concentration of these two are with respect to equilibrium concentrations. And the equilibrium concentration can be calculated using the KSP, which is the equilibrium constant for this dissolution reaction, right? So C, by virtue of that, is the right answer right away, okay? But to understand that, thinking about what KSP actually equals to, the KSP as an equilibrium constant is just going to be equal to the concentration of the reactants, okay, raised to their exponents, multiplied by each other. So this would be the KSP equation. Now notice that we don't put the reactants here, and the reason is because the reactant is a solid, and we have to exclude any solid phase or liquid phase reactants or products. We only include aqueous phase, right? These are actually just ions dissolved in the solution. So this would be the KSP. And what we would do is we would calculate the concentration of the lead and the chloride at that particular time, and we would compare it to the KSP. And so that would be the reaction quotient. So the reaction quotient would simply be the same equation as the KSP, okay, but for a specific point in time. Okay, so we would calculate this product, right, and then we would compare the value of Q to the value of KSP. And if Q is greater than KSP, that suggests that there are more products than there should be at equilibrium. And so these products would react according to Le Chatelier's principle in the reverse reaction to produce more of the reactant, okay, and that reactant is the salt, so you would have some precipitate, right? And you could figure that out if you knew the KSP.